And then Randy Cook with OMG Solutions is going to come up and do the same, a short demonstration of his products, very similar to what it says right here. And then after that, right here in front of you, we're going to do a live demonstration. Just like what Jimmy said, we're going to take clean soil, show that it's clean by testing it with our product, and then Randy is going to contaminate it and use his product to actually break down the hydrocarbons in real time. And I think we're going to go from about 100,000 down to about 5,000 ppm in about 10 minutes. So that's the process for today. So what we manufacture is TPH field test kits for water and soil analysis, and we've done it for the last 30 years. And so we just kind of want to give you an idea of what goes on. What's your options when you're out in the field to analyze your soil sample? So there are field devices such as PIDs that give you, what we got here on the Y is the time to get your result, and on the X-axis here is the quality or data of your data that you get from there. So you have these other field measurement devices such as a PID or a VOC that they're very, very quick to get your answer, but as far as quality, you can't rely on them for anything. But they're very, very cost effective, very, very low cost. Your other end of the spectrum is you can send your sample off to a lab to get your result. So it takes a little bit longer to get that lab result, but it's a very high quality data that you're getting from that lab result, but it's a lot higher in cost. And what you can do is you can pay a little bit more and get an expedited lab result, which would cut down the time to get that result, which is normally in tune about 48-hour turnaround to get that result back from the lab. But that expedited time, jumping to the front of the line, increases that cost. So where do we fit in with our field test kits? We fit in right here. Our price is about the same as any other field measurement. The quality of your result is just about in line with a lab result, which was found by the US EPA and the US Army Corps of Engineers to be within 10% of a lab result. And our cost is very, very lower than a lab result, but more in line with other field measurements. I mean, you're getting your result in 4 minutes for soil analysis and 6 minutes for water analysis within 10% of a lab result for $25 a test. So this is a picture of our field test kits. This is our water kit here. This is our soil kit here. You know, a kit comes with 15 tests, and each refill set has 15 tests in it. A kit is $12.95 and a refill set is $3.75. So initially, the first time you buy a kit, your cost is $86 a test, which is the $12.95 divided by 15. And then you really realize the economic value behind it when you just start getting the refill reagents to do analysis, because at $3.75 for sets of 15 tests drops your price to the $25 a test from then on. So the detection limits for our kits, we have 2 soil kits. We have a low range, which goes from 0 to 1,000 ppm, and we have a high range, which is most applicable in most oil field applications, which is the lowest calibration is 500, and it goes up to 50,000 ppm. In both cases, there's a 10 mil graduated cylinder included in the kit, so you could do all the way up to a 10-to-1 dilution and increase that upper limit up to 10,000 on the low range or 500,000 on the high range. Our water kit is centered around low concentration. It's ppb versus ppm. So 0.1 is actually 100 ppb. So we're talking about parts per billion instead of parts per million. And that's because in most of our applications where our water kit have been used, it's looking for low concentrations of crude oil or fuels in oil or in water. I mean, our water kit's actually been used on every major oil spill since the Exxon Valdez. At the Exxon Valdez, they flew my grandfather up to Alaska, who's the founder and inventor of our company, Mr. John Hanby, and he went around and trained the staff at the fish hatcheries up in Alaska on how to use the water kit to know when to release the salmon spawns so they didn't die after the spill. So the other, major event, the largest inland spill in U.S. history was the Ashland spill along the Monongahela River, which is Pennsylvania and Ohio. And it was 0 degrees outside, so it was so cold the water would come up over the front of the tugboat and freeze. Well, there were only 2 things on that boat to use to analyze water samples, our water kit and a fluorometer. Well, because the generators were malfunctioning because it was so cold, the fluorometer wouldn't work. The only thing they could use to analyze water samples were our kit. So what are the values that you get from using our kit? You're getting very, very accurate results. As it shows here, as I mentioned earlier, they've been validated by the US EPA. Your results are 4 minutes for soil analysis, 6 minutes for water analysis within 10% of the lab result. Very, very portable. These kits come in a very rugged case. You can throw them in the back of a pickup, drive down the road, let it bounce around, and the glass that's in them is perfectly fine because of the foam that's in there. So 4 minutes for soil, 6 minutes for water. They weigh about 12, 13 pounds, very, very easy to use. For the last 30 years, there's been nothing but some paper instructions in the kit. If you, most recently, if you want to see a video of my grandfather doing demonstrations, it's online on our website. Nobody's really needed any training. It's very, very simple, which you're going to see here in a second when I go step by step through the instructions. But most recently, we were asked to start a training course, and we actually put that in place. The California Department of Transportation, Caltrans, requested that we do that, and it was recommended by a state health inspector from San Joaquin County, which is one of the more difficult or stringent counties to deal with in California. But they said, hey, instead of us showing up on site to these spills on the highway and validating that you're using this kit properly, if you guys get Hanby to train you guys to certify that you've been trained to do it properly, then we don't have to show up and validate your results anymore. So it's because of that we put that in place. So we do have a certification course if somebody needs it, but it's not necessary to do. So this is like if you were doing a soil analysis, these are the 6 easy steps to do it. Everything's included in the kit. First thing you would do is pull out your scale, put an empty beaker on it, tear out the weight of the glass, and then add 5 grams of soil, which is the commonly accepted soil sample size. After you've added your 5 grams of soil, you put our extract solvent on it, you stir it around for 30 seconds to do the extract. That solvent is pulling out any hydrocarbon that's present in that soil sample. You take out a test tube and you pour it up to the scribed line on the test tube. You add the white catalyst powder, the color development reagent, and then you shake it for 30 seconds and you compare the results to the calibration photos that are included in the book and the kit. So 4 minutes for soil analysis. These are the type of results you would see. It's a colorimetric or visual test. So you take your result and you place it between the calibrations in these photos. And so if you like say here for gasoline, for example, you find that your result falls between the 80 and the 100 ppm, you can say either it's 80 or you can say it's 100, or maybe you say it's halfway between, you call it 90 ppm. All of us have different types of eyes. We see things slightly different, but none of us are going to see it different whether it's above or below the typical threshold, which is 100 parts per million. As you can see, the gasoline typically has a yellow, orange, red tint to it versus, say, diesel that has a tan to brown tint to it. Similar to most crude oils, also have a tan to brown. Similarly, for water analysis, the only difference is the extraction process. Instead of using a beaker to measure out 5 grams of soil, we're going to use a 500 mil separatory funnel. 500 mils is commonly accepted as the normal water sample amount to get a good representative sample of what's around you. That's typically even what they use in the ocean. So what we do here is we put our 500 mils of our water sample into the separatory funnel. We add our solvent into the top. We swirl it around and shake it around to do the extraction as that solvent is pulling that hydrocarbon out of your water sample. It's heavier than water, the solvent is, so it separates the bottom after you put your separatory funnel in the 3-ring stand. You can see this separation right here is the solvent down at the bottom. Water has a 1.0 density versus our solvent has a 1.6 density. So after swirling it around and shaking it around, it does the extraction, separates the bottom. Then you put the test tube under it and you let it out to the scribed line, add the catalyst, shake, instantly develop the color. So about 4 minutes for water. Again, these are samples of the type of results you would get there. Here's gasoline and water, here's diesel fuel and water. Here's Macondo, Deepwater Horizon, here's some condensate, toluene. So again, just going through quickly of the 6 steps. You add your water sample to the separatory funnel, you add your solvent, you swirl or shake it around to do the extraction, you see the separation, you put your test tube under, you release the extraction to the scribed line, add your catalyst, shake, and compare it to the calibration photo. So, as I mentioned earlier about California transportation, this is actually a testimonial from Caltrans, unsolicited. Just that there's a lot of text here, and he's going to publish this presentation so you can read it in full detail, but just to highlight a couple of things. The problem that we're experiencing is that we can't get the lab results back right away. I've used this kit now in 4 different counties on several incidents with lab results also taken that have come back with the same results. Testing only takes a few minutes and can immediately know if the site is clean or if we need to further excavate. So Scott Waller ran District 10 for Caltrans, and actually was the one who first found us, who made it instrumental, and now the entire state, all 12 regions of California, use our kits to respond to spills on the highway. City of Corpus Christi, this is their testimonial. This was, they gave us this in January. The Hanby kits is an analytical method, portable, easy to use. This is what she says. I actually think the more relevant line is right here. We have utilized and continue to utilize the results as a quantitative pass-fail method for source tracking. So basically what they've actually written us into their standard operating procedure. And it says, you know, the detection limit they're looking for is so low that they don't even care what the quantification number is. It's either stays white or it doesn't. It's either pass or fail. Paracon, a very large remediation firm out there, here's what they said. The Hanby kits were used to help them to figure out the extent of groundwater contamination, and it was also verified by lab results as well. So again, just to quickly just revisit some things. Here's our field test kits, which is a visual method. I'm talking to Jimmy and Monica about coming back at the next quarter meeting to do a presentation on this technology right here, which is the same chemistry that we use here in the field test kit, but now replacing the human eye as the optical with a UV-vis spectrometer. So now we have a standard eye, a computer eye, if you will, and that spectrometer changes this color into spectral curves. And these spectral curves represent a fingerprint, so we can literally fingerprint hydrocarbons. It's like doing DNA analysis. We can tell you which well it comes from. If there's confluent formations, we can tell you, how much of each is there. Because unlike what they do in a laboratory today, they use a GC mass spec, which separates things based on weight and molecule size. But what they do is say, if there's benzene present, they look at, like, say, 400 nanometers, and there's a peak there, and they say, oh, there's some benzene there. We don't know how much, but because that peak is there, there's some benzene there. Well, our spectral fingerprint curve is not at one peak, it's over the entire wavelength. All of those things combined is what makes that spectral fingerprint. But in any case, so I was saying I was going to see if I can come back next quarter and do a presentation on this. But what we have coming out as a complement to our field test kits is we have a mobile app. In about 2 months, we're releasing this mobile app, so now we've standardized the eye so that you don't have to worry about the subjectivity of the eye anymore. You're going to actually take a picture of your result and use the camera on your phone. The app will calculate the concentration for you, as well as everything will be stored in the cloud at this point. So every analysis that's ever been done will be stored there. You can refer back to them. You're getting a report that you can instantly share from the field. And this is this type of stuff, so there's just kind of some samples here. Like, here's new analysis, here's past analysis, here's a sample of the type of report. That's what we have coming out. So just to summarize real fast, a comment from an environmental consulting company. Clearly, the Hanby kits are the best tool when you need reliable data to help guide your field work, striking the perfect compromise between data quality, speed, and cost. So with that, I'm going to turn it over to Randy, who's going to do a presentation on his hydrocarbon elimination.
My mama gave me on recording this thing. Okay. Hello guys, I'm Randy Cook. I'm with OMG Solutions, and we're out of Victoria, Texas. For a little background for me, I did stay about 20 years here in Oklahoma. I graduated Seminole State College there in Seminole, Oklahoma, and after I did that, I said, now what I'm going to do with my life. So my father was down in South Texas, and he was in the oil field and invited me down, and I decided, what the heck, I'll go see what this stuff's about, and once it's in your blood, it's in your blood. So that's what I've been doing the service part of the oil and gas business for the longest time. So basically, I'm just oil field trash sitting here in front of me trying to give you a presentation, so bear with me. But ran across, for years and years and years, we've been taking oil spills, and we'll take them and bring in some dirt, we'll cover it up, and hopefully it goes away, and next day, a good hot day comes, it's bubbling right back through it, and okay, so now we're going to go dig a hole, and we go throw it away. Anything under 5 barrels in Texas, we just got to get rid of it. So I tried multiple times trying to find things to do. Just being honest, we all been there and done that. But he just, so we tried microbes, we tried enzymes, we tried all this stuff, and it just all takes so much time, and just get to the point where we just kind of throw our hands up. And I came across this product, this brought to me over a year ago, and I started testing it because it has a pretty good reputation in South Texas for myself. And the last thing I want to do is bring something out somebody's going to call snake oil. And so I said, okay, well, I want to play with it. I started playing with it, and everything I tried to do is just make it fail. I just wanted to make it fail, and I just never could make it fail. So basically, this is our little presentation here we got. Is that how that clicks? Oh, there we go. So we're going to run through a few things right quick. We're not going to take a lot of your time because I'm obviously not good at what I'm doing right here right now. So oil spills are an inevitable problem for the oil and gas industry. Of course, they're still happening as we speak. So there's many solutions. You know, the dig and haul method, which becomes very expensive. We do that. You know, around $55 a ton per se. And and you got to dig it all out. The landowner says, looking at all the dirt take off and going in the trucks, and he's getting upset. And you know, so we try microbes, and like I said, they take so long, 6 to 8 weeks. They do work. I'll give them credit. They work, and they're still a little expensive too. And depending on whether weather related, I mean, sometimes your microbes can just blow away in the Oklahoma wind, and so it's always been a challenge for everything. But like I said, the enzymes, sometimes, you know, people go, the enzymes are worse than the actual total hydrocarbon that's out there. And I've actually seen it happen. They come back and test and just rather not use that stuff either. So basically what we come down to is you guys want to know what's in it. Everybody keeps wanting to know what's in it. So this is a good example of what's in it. I'm no scientist, so you guys can probably read that language better than I can. But basically it is no enzymes, no microbes in this stuff whatsoever. It actually molecularly breaks down the chains of the hydrocarbon, and it does it very, very rapidly. So we get to playing with it, and I'll leave that up for a few people that are reading that can make sense of it than I can. And so we've tried it on water, and it immediately takes it and breaks it down with water. The difference with it on water, again, like even the BP disaster, was, you know, surfactants generally take the oil and sink it to the bottom. Well, this does not do that. It actually sits on top of the oil, and once it breaks down, it turns to a dust. And that biodegradable dust goes down the bottom. You pick that back up if you want to, and it's completely clean. So we been experienced a lot of it on water, and then we started playing with soil. And we had a example. Our last test we just got through being on. We were over 600,000 parts per million. That's 60% oil. So they won't dig all that off either. So we had a challenge there on our hands to see if we can get that back down, and we actually got that back down in 7 treatments. We got that cleaned back up, and we're around 5,000 parts per million today with it. It's basically real simple, guys. It's not a real laborsome thing. I can send 2 guys out in the field. We have a pressure washer unit we've got designed to slow down and be able to apply the product. Water is its best friend. In order to keep it activated, it never stops eating unless it runs out of water or runs out of oil. So every day it gets cleaner and cleaner and cleaner until it rains. So water's the best friend. So basically we come in, we flood the area with fresh water, then we'll go back in, and tilling it is most efficient because depending on what it is, I mean, we're at some depths of 8 feet deep, it's no problem. We actually drill holes, and depending on the permeability of the soil, it'll actually soak through, and we can actually get through that way too for deeper spills. But generally we're messing with around 6 inches to 12 inches, and we come in with our tiller systems, and we come in, we till it all over, and then we retreat again, and we just repeat that process, and then once again go back to the water next time, depending where your ppm is. We're knocking out average of between 30 and 40,000 parts per million out of treatment. So, and this is a big problem. This is the reason we found Mr. Fader over here. We ran into this problem. This is one I was telling you is over 600,000 parts per million. Pretty good little disaster there. And this is a saltwater line, by the way. So, where did the oil come from? But just to go into it, so we get the lab reports back. Well, it just so happened we have a lab report, and then we have a company that comes out and pulls the samples for a third party because we don't want nothing to do with it at this point. We want to completely nothing to do with it. We're still in testing stages of this stuff. And they come out, and just so happened one guy hasn't paid his bill to them, so it takes 3 weeks, and it comes up to 4 weeks, you're still not getting the results back. So finally, I go and buy the results. because I had to have the results. Railroad Commission down there is already on our tails, wanting the stuff cleaned up. And also it comes back 107,000 parts per million. So good old Randy, oilfield trash Randy, goes out and bids the job at 107,000 parts per million. I can clean it up in 3 treatments, I'll be out of there. Well, then we go out with Mr. Hanby's kid over there, and we come to find out we're well over 500,000 parts per million. So guess what Randy gets to do? He gets to eat the next 34 treatment. Never gonna happen again. So we go out and we kind of explain to the company, you know, well, it's going to be more than that, and they don't hear it. And you tell me it's 107, that's what it is. What the lab report said. We don't believe your little tailgate stuff. You know, it's okay. We're all right. So we did. We went out. We honored it, and we still got it cleaned up. And it cost me more money than what I wanted it to. But look, I get to talk about it now. So, the takeaways from this today, I want you to know is that solution breaks down total petroleum hydrocarbon at a molecular level, and is really environmentally safe. I'll spray it in my mouth a little bit just to tell you how safe it is. Jessica hates it when I do that. Our proven remediation process, you know, we have been very successful on multiple projects and on multiple levels, and we can save a ton of money when it comes to dig and haul method, and even sometimes even the flyaway microbes. So we believe every spill control countermeasure ought to have this on hand. Depending how many barrels of oil you're producing, you ought to have X amount of gallons of this stuff, so if it happens, you can get rid of it immediately. So that's just something we're going to provide for you guys today. And appreciate you inviting us up here. Sorry I'm not much of a speaker, but I think you got the gist of it. Last thing, we definitely want to thank Mr. Fader for his time and inviting us to this thing, and he's been a tremendous help to us. And with that, I'm going to call Jessica up, and she's my lab tech, certified lab tech girl, and she's going to put on the show.
I don't want to wear the Britney Spears mic.
Yeah. Work. She never says anything.
Hi guys, how are y'all doing today? Great. Good. We drove up here from Texas yesterday. This is the longest I've ever been in Oklahoma. It's pretty cool. I like the dirt.
She likes the red dirt.
I think it's cool. We don't have that in Texas. So.
See how close I can get before feedback happens. Yeah, good. All right, so basically what we're going to do here is going to do a demonstration where we're going to use our kit as the validator to show, you know, the progress of the effectiveness of their product. So first we're going to take some soil out here and we're going to test it. We're going to make sure it's clean. And it's going to be clean by the representation of white. From our case, white represents a blank, which I've actually put up here on the screen. So blank is how our catalyst starts. Our color development reagent is a white catalyst powder. It's 1 gram of aluminum chloride. So it starts out white, and after you use that extract solvent that would pull out any hydrocarbon contamination, you add it to that white. If it stays white, that means there's 0 or non-detect, there's no hydrocarbon contamination. Any tint of color whatsoever means you have detected hydrocarbon contamination. So what we're going to do here is we're going to show that the dirt they're using is clean. Then we're going to contaminate that dirt right in front of your eyes. And then we're going to apply their product and start knocking down the hydrocarbon contamination in real time. So as you can see, she's got her safety goggles on, her glasses. Everything you need to do analysis is included here in the kit. There's that feedback. So she's pulling out her scale right now and putting her empty beaker on it, as we went through the steps earlier in the slide, and hitting the tare button, taking the weight of that scale out, or that beaker out, and then she's going to measure out the 5 grams of soil into that beaker. Now, since we have time lag here, I like to knock on the EPA a little bit. So there's an EPA method for soil sampling. They have this plug tool. It's a T tool. You plug down into the soil and you turn it and you measure your 5 gram soil sample that way. Well, my question is how does 5 grams measured by volume inside that T plug weigh the same if it's a sandy sample versus a clay sample? So a very, very flawed method, inaccurate way of measuring your soil sample. The most accurate way to measure your soil sample is by weight, because, you know, if something weighs more or less, you'll have more or less material, such as measuring it by 5 grams by weight, like we did. So she's added her extract solvent to that sample, that affect anything? It does not. Your result will have a couple of black specks in it, but it is not going to affect the color that we're developing whatsoever. So, all right, you're going to have the fun. That thing is sealed. So she's pulling out the color development reagent, and inside there we've got it in a jar with silica gel, because that 1 gram is in each one of the vials. 1 gram of aluminum chloride is measured out very accurately in a glove box, because it needs to stay anhydrous or dry. And so we used to just keep it free floating in those jars, and actually I've got some back 7.5 years later. It's perfectly fine. Of course, we sell consumables, right? So we don't really like that. But what we've done is now we've started vacuum sealing them in these bags, because it's just important to keep it dry, because any hydration is going to slow down the chemical reaction by clumping up our catalyst. Additionally, by vacuum sealing those, we're keeping them upright so that the catalyst doesn't react with the cap liner. But she's adding that color development reagent to that extract. If there was anything in there, instant color would have popped. You would have seen it. Even before shaking it, instant color would pop. Also, this air is on the high side. The only thing you could possibly do is not get all that catalyst out of that vial in the transfer process, or spill some on the ground or something like that. Well, remember, there's 1 gram of very accurately measured out there. If you got any less into your test tube there, it's actually going to produce a darker result. So you're going to get a higher concentration reading than the actual, because of the fact that you spilled some or didn't get it all over. But in this case, as you can see, it stayed stark white just like it started. That means there's no hydrocarbon contamination in that sample. So bring on the 35 gravity crude oil. Who's big out here? Continental? Okay, so Continental is going to have a little pipeline leak here in a second.
Anybody from Continental here today? Nobody from Continental? Oh, you are? Okay, there we go.
Okay, we'll blame it on Hess then.
We stand across.
This is Hess.
we stand across from the Sheraton from y'all, so we get picked on.
Okay, this is Hess. They don't even have wells there. We'll blame it on Hess.
Don't hurt so many.
So we've got our clean dirt. Now we're going to contaminate it. Or is this from that McFadden?
That's actually McFadden oil.
It is? Okay, so then who spilled it?
Frostwood Energy.
Frostwood Energy. Okay, so this is Frostwood happened.
We can throw them out of the vessel all you want to.
So we're simulating an oil spill or leak right now by contamination of that soil sample.
She forgot to start her tiller, and I'm going to start that for you. Well, it has to make it work out running.
She's a pro. We did this, 7 times at TCQ?
Yeah.
Yeah, this is the yellow tint of the solvent.
What did you do?
Look at that. So just right there, we already know there's high contamination in this sample. Now we're going to add that color development reagent, which for people that want to know, again, it's 1 gram of aluminum chloride. The 10 mils of solvent is 10 mils of heptane, for those that want to know. Notice above that scribed line, if you can, there's already color that instantly developed as soon as you put it over before even shaking it. Bang. Look how dark that is.
You got some work to
So,
do, Jessica.
what happened to our...
No signal.
Okay, so that first sample, look how it ends up way over here on the right at 100,000 ppm. Okay, now the magic happens.
Go for it. Start out with water, like I said before.
So the activator is water. Water is the best friend. So she's saturating that contaminated soil sample with water.
I like the microphone too much.
So you have a power sprayer that you use to go out there and apply the water, and then you add your solution.
Something a little bit like Bob Bill.
Thank you. Best compliment I've had all my life.
Okay, we've saturated our contaminated area. Now we're adding the solution. Do some further tilling. Start your tiller up again.
Sometimes it goes brum, 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 on switch. I get bored easily.
I was going to go through the steps, but we'll just leave the picture there. So here we go again. We've got our empty beaker. Tear out the weight of the glass. Add in 5 grams. Just a little background. Hanby Environmental, John Hanby, my grandfather, founder and inventor of the company. He ran the lab at NASA for 10 years before he started this company back in '86. So 58-year environmental chemist. So that's how the chemistry part came into existence. So getting our 5 grams at 5.00000.
Not expecting any other. .01 on that one.
5.01.
She gave up.
That's good. Adding our extract solvent, 10 mils of heptane.
Somebody give me a Justin Timberlake song.
Stir it around into the extraction process. Let's see if the magic works. Let's see here.
May not work in Oklahoma. I know when I was there, I didn't. I'm in the South. Detailing cars for a living.
So pour out the extract up to the scribed line, which again represents 4.2 of the 10 mils.
Lighter.
A little bit lighter in color. But let's really look at it. Let's add the catalyst. Again, 1 gram of aluminum chloride.
Anybody here in Murphy Oil today? Nobody at Murphy?
Shake. So put them next to each other. Let's visually see the difference here. Is it lighter? I can't see from over here. Okay. So I guess all the clay sand doesn't affect the result. So it does work in Oklahoma.
So far, so good. I wonder if it works on red dirt or not. Yeah, let's break it on down.
One of the questions we get asked all the time is soil type having to do with it, and absolutely not. Again, measuring it out by weight. It doesn't affect our extract solvent. The only difference is in the extraction process. If you got a sample that's got more clay in it, instead of just stirring it around like you do when it's like sandy, you actually will chop it up a little bit and smear it around. All you're doing is increasing the surface area that is coming in contact with that solvent to do the extraction process. But the type doesn't affect the result whatsoever. It works on all of them, including mud. In fact, what we're doing things on these days is drilling mud, cuttings, core samples. We actually did a big project for Hess on core samples from the Bachman and Three Forks. The initial question there was, could we tell the difference in the Bachman and Three Forks? And we said, absolutely. And they said, well, they come up commingled. How do you do that? And said, give us the core samples. So we got 32-inch plugs, crushed them, did our extraction process from them. But that's when we're using that fingerprinting. But, just saying, we can use different types. It doesn't just have to be soil.
How much time is required between treatments?
That is a randy
That
question.
is, you can literally go out there in a day's time and get it knocked out. What we have tomorrow is a job for Murphy Oil, and that's just what the phone call was earlier. He said, well, this is going to be like a 2-day process. I said, if I'm there more than 4 hours, something's wrong. So, I mean, it's low labor.
What he said, it's like 14,000 ppm.
Yeah, 14,000 ppm. We'll just sneeze on that and knock it out.
One application.
But they're so used to micros, used to everything else takes so much longer to work and do its things. But it's like I said, it's a very interesting product.
So each application typically is 30 to 40,000 ppm knockdown. So they have their deal at 14,000, just one application. Really is going to be dependent on the size, right?
And they're very concerned with their level of benzene, and we're just kind of trying to get them to explain to them the benzene part of BTEX, and the biggest part of oil is your benzene up top. And I see where it doesn't total patrol hydrocarbon, but we'll work on benzene. Yes, he's gonna knock that out. And he's like 0.28 over standard, so it's like it's gonna be a big deal. So
Yeah. So the thing is he's at Murphy. They're concerned about benzene, so I assume that everybody else is worried about benzene, such as they do in the refineries as well for B1. But benzene is a part of BTEX, and the reason why it's the first letter in the BTEX acronym is because benzene is the major contributor there. Same thing, BTEX is the major contributor in TPH. It's there. So if you lower TPH level, you're obviously lowering benzene level as well. So if you can get the TPH level to, 100 ppm, then you can know that there's no benzene, maybe a trace. So as you can see, bam, bam, bam. Whoa! Oh, you see how strong our test tubes are? Hey, thank you for that. I know you did that on purpose.
I look for
But,
no, you can't. Really, it's good.
so again, right there, you've got the white, which represents the blank, where there was no contamination. Then we contaminated it to 100,000 ppm, dropped it down to whatever that number is, 20 or 30,000 ppm, and then dropped it down to, say, between 2 and 5,000 ppm. Just like that, in like 15 minutes. Does it work? Yes. There's no question that it works because we are doing analytical chemistry in real time. Chemistry, doesn't work or doesn't, it is what it is. I mean, so we use an extract solvent, pulled out the hydrocarbon, and it got lighter and lighter as they apply their product. So absolutely it works. Our kits have been around for 31 years, been deployed all over the world, and honestly, we have lots of companies. Like the largest utilizer of our kits are remediation companies. The second largest user of our kits are actually companies that have a product that they use in remediation that cleans stuff. Met Randy about 6 months ago, and I said, man, that product is amazing, and actually I think that we should do demonstrations together. I have lots of companies like his that use our product. The problem is none of them can have the speed to do a demonstration. And when I saw the speed of his, I said, man, this is perfect. We can both do live demonstrations to show people. Because at conferences, when we do stuff, we do demonstrations in our booth all the time. Typically, I just, add some gasoline or diesel, whatever, develop that color. And it's like a magic show. People see that color go from white to something instantly. So people like that. But I was like, now to go the other way and have a purpose in it and show you reducing that hydrocarbon contamination, I think this is a perfect joint demonstration tool.
Yeah, it wasn't for Hanby. We couldn't show these results like this. We have so much. I mean, I could have bored you to death all the oil spills we cleaned up and test results and lab reports and everything else that we've done before in the past. And you look at that and go, I can Photoshop that too. And you know, so it just to actually be able to come out and do it live and just really shows it hands-on and you can see it before your own eyes. It actually does the job, and it does it immediately.
So that's really the conclusion, and you know, we thank you for the opportunity to be able to do this. I mean, is there any questions that anybody has that we should answer? Yes, sir.
After you have the test run, what do you do with the solvent?
Great question. Great question. Included in your kit is a waste bottle. So you would actually go and pour off the solvent into your waste bottle. And what I love about that question is this solvent that we're using, heptane, if you leave that solvent in those test tubes, that chemical reaction is going to continue to take place for about 48 hours. That results can get darker and darker and darker. That's why when you do an analysis, even right now before we release that app, what we recommend is you snap a picture of your result with your result compared against that calibration photo, because at time, date, and GPS stamps when and where that analysis was done, so you're capturing that result. And then you pour that solvent off into the waste bottle. Otherwise, that chemical reaction is going to continue to take place, get darker and darker, and eventually it's going to get like a maple syrup dark. So you just pour it off into the waste bottle. The same thing you do with this excess solvent that is remaining in your beaker, you pour it off in the waste bottle. But remember earlier I had mentioned that there's a 10 mil graduated cylinder included in your field test kit. If you were working either in the low range and you were over, say, 1,000 ppm and your result went black, or here in the high range where the upper limit is actually for the Railroad Commission's Rule 91, it says in the event of a spill, you immediately have to clean it up to 50,000 parts per million or 5%. Then you get a 30-day window to get it further down. Let's say that it was 100,000. Well, in this case, you can actually see that 100,000. But in some of the other calibration photos, so like diesel, for example, if you were at 5% or more, it's going to be dark to black. But let's say you wanted to know what that number was. You would use that 10 mil graduated cylinder, you would pour off 1 mil from its original extract and grab another solvent and dilute it to whatever ratio, whether it was 5 or 10 that you wanted to do, and now you just, whatever result you get when you compare it to that calibration, you multiply by that factor to find out what that over the 50,000 parts per million concentration is. So again, you just take this stuff and pour it in the waste bottle as well.
Right, and the McFadden spill we're speaking of is over 600,000, so we were black here. There's no red tint to it all, it's pretty little black. You know, when she did the 10 mil, come back to it, we're still around 50,000, so you had to have the twist. Right, so add a zero to it, so it's your 500,000 plus. So. And I said,
yes, sir.
You say this reaction breaks the hydrocarbon molecule down and consuming it?
yes, sir.
What's it do to natural bacteria in the soil?
That's actually what it's activating. It's actually activating the natural microbes that are in the ground. It's helping those activate and help the molecular process.
So we do have to have naturally occurring bacteria.
In all ground does. Naturally, we all have microbes in all the natural ground. So you're just utilizing what's there and working it.
It's like crack for bugs.
Yeah, yeah. Literally. And the sanitizer is water.
Go ahead.
You mentioned the Railroad Commission standard earlier. Does this serve as confirmatory sampling, or do you have to follow up with
So what we recommend is the real value here. The Railroad Commission loves us. In our state, TCEQ loves us. California loves us. Colorado loves us. In fact, Colorado, for the last 15 years, has had it on their reporting form. You use the lab result or use the Hanby method. I was talking to a lady at a conference the other day. She was like, I was always wondering what the Hanby method was. Now you know. But so Railroad Commission loves it. But what we still recommend is, you can eliminate 90% of the samples that you send to the lab and doing it in real time. But once you're done, you still want a third party to sign off on it. So then take your confirmatory sample and send it off to the lab and let them do it. And then you already know what the result's going to come back as, most of the time. Because we've had some recent events with that large remediation company up there, Terracon. We actually became the check step for the lab. What happened if you send a lab, sample to the lab? Nope, it's hot. Go back out there and dig some more and bring us some new samples, and it becomes a cycle over and over again. Well, They went out there. You could see it, smell it. You knew that it was contaminated. They were doing dig and haul, taking it out of there. They were testing it the whole time. It got lighter, down to 50 ppm, and ultimately non-detected, stayed white with our kit. They took samples, sent them to a lab. Results came back 3,500 ppm. It's impossible. If you're 1,000 or more, it's black. They're using our low-range kit, so it's impossible. So they took a second set of samples and said, okay, we'll send them back to the lab and see what happens. Result came back the same, 3,500 ppm. They called me up, Charles, we got a problem. We know it's not your kit because, you know, we've been doing this forever and we did dig and haul and blah, 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 blah. So yeah, that's crazy. So they took a third set of samples, sent them to a different lab, results came back non-detect, just like you anticipated them. What's the problem there? Nationally certified laboratory didn't clean out their GCMS spec. So had they not had our field method to know where they were at as a check step against the lab, well, go get some more samples, keep digging. Over and over. So that's like one of the only times we've really had discrepancies with a lab. But I mean, so there, I mean, a field analytical tool has its place. So you know in real time. Otherwise, you know, take forever to get your result back, and you got equipment sitting there, you got people sitting there. I mean, that's the biggest cost. It's not the difference in the cost of a lab test being, you know, $100, $120 for a 10 to 14 day turnaround, or expedite it. It's like $300 to $500 to get it back within 48 hours versus our $25 a test. That's not the cost savings. It's the equipment and the operators of the equipment that are sitting there idle. That's
Time is
the hidden cost. Anybody else?
She had a question up here in yellow.
How does temperature affect the activation of the
Higher temperatures do not affect it whatsoever. The lower temperatures, if you're starting to get around freezing point, it does slow down the process considerably, almost to half.
Oh, time. Yeah. Yeah. Okay, well, thank you again.
I got